Hi, I'm Melanie Jackson, and I'm a PhD student working here at Horn Point Laboratory, University of Maryland Center for Environmental Science. And I study oysters and how they remove nitrogen pollution from the Chesapeake Bay. So I'm sure many people have heard that Maryland had one of the largest oyster fisheries in the world in the late 1800s. And over time, we've seen a major decline due to overharvesting and loss of habitat, as well as the appearance of diseases such as MSX and dermo around the 50s appear in the bay. Because of that, we've seen that our oyster population is less than 1% of historical population values today. And so, because of that, we've seen that there's been a major goal from state and federal agencies to increase oyster restoration in the Chesapeake Bay. In fact, goal is by 2025 that there will be oyster restoration in at least 20 of the tributaries in the Chesapeake Bay, some of which are just outside our door in the Choptank River. And I actually get to study oyster restoration in Harris Creek. But because of the cost of these projects, and we're trying to increase commercial harvest, we're also trying to see whether or not these oysters are helping improve the water quality in these restoration sites and how much pollution they're removing. We've seen that these oysters, they are filtering the water column and removing algae and particles from the water, and they're using part of that for growth, but they're also depositing whatever they can't eat or can't process as biodeposits that go to the sediment. So they're taking that pollution that's in the water column, which drive and feed algae and allow algae to thrive in the water. And these oysters are filtering that algae and essentially pollution from the water and bringing it to the sediment. And so, other than that, we're seeing that the oysters are assimilating or taking nitrogen into their shell and tissues. But other than that, we're seeing that these oysters are a hotspot for nitrogen removal, which the word for that is denitrification, where you're converting nitrogen pollution to a non-harmful gas, which goes into the atmosphere. And this is a process that actually wastewater treatment plants use to remove nitrogen pollution in sewage. But the oysters are creating this hotspot with all of this organic matter that's rich at the bottom, that all these microbes or bacteria can convert it to this non-harmful gas. And that's something that my lab, way before I even started as a graduate student, has been measuring. And we've seen that the more oysters you have, the more nitrogen that is removed. And the more oysters you have, we've also seen that there are more organisms in the water, such as crabs and mussels and barnacles, where some of our previous measurements have shown there are 12 times as many organisms on these oyster reefs than non-restored sites. Usually the way that we measure this nitrogen removal is by taking these huge trays, and divers fill them up with sediment and oysters, and these trays go out on the restoration site for about a month to acclimate. And so you can imagine this takes a lot of time and effort and a whole team of divers and scientists. So my interest is seeing how we can improve this and reduce the amount of time and money that we're spending on this. And so I've created this water sampling device where we have over 40 feet of tubing attached to a tripod that sits on the oyster reef, and we can see how the water quality changes as the water flushes over the oysters, and we can see that there is nitrogen being removed over the reef, which is very exciting. And so hopefully we could still keep seeing those oysters numbers increase in the bay, not only for improved water quality, but for more harvest.